So the last section, or the last part of this section on exponential and logarithms is hyperbolic trig. So you might be saying, what does trigonometry have to do with any of this with exponentials and logarithms? Well, there are two functions that we're going to look at, hyperbolic sine and hyperbolic cosine. Now these are interesting in that we'll see later why they're going to be very helpful to us when we learn derivatives, but I think it's important just to know the definitions of them. So first is hyperbolic sine. This is just sine with an h, that means hyperbolic sine. Hyperbolic sine of x is defined by e to the x plus e to the minus x over 2. So this is how hyperbolic sine is defined. It's defined in terms of exponentials. You could also have hyperbolic cosine. That's defined by e to the x. Oh, I got this wrong. This should be a minus up there. This one's the plus. So hyperbolic sine, hyperbolic cosine are defined in terms of e to the x. If you want to figure out what is, hyperbolic sine of 2, it would be e squared minus e to the minus 2 over 2. Plug that in your calculator and get some sort of decimal approximation. So these are the two hyperbolic functions that we're going to work with. It's just important how they're defined. One important property, though, of these, this is probably the most important property, is that hyperbolic cosine squared minus hyperbolic sine squared is equal to 1. So it's almost like the stuff we were doing before with cosine squared plus sine squared equaling 1, but hyperbolic is slightly different. So this is going to come back whenever we start doing derivatives, but for now, you just need to know how are they defined in terms of exponentials and how do you find a decimal approximation. So that's all you need to find for hyperbolic trig.